All right, let's go. So, trigonometry. Okay, so what I'm going to do here, okay, so I'm going to assume that you've never learned trig before. Okay, so what we're going to do is we're going to take the Cartesian plane, okay, and centered at the origin, I'm going to draw a circle that has a radius of 1. Okay, that's what I'm starting with. Okay, that's where trigonometry starts, is everything's happening in this, on this circle. Okay, so what I'm going to do is I'm going to try to find some important points on that circle. Okay, so the most obvious ones are, of course, this one here. What is that point? What's
1, 0.
1, 0. This one on top is
0, 1.
0, 1.
Minus 1, 0.
0 and 0 minus 1. Okay, we're good. So, what's very important for me, what I'm interested in, is in determining what the coordinates of the points on the circle are, depending on which angle I am opening my radius with respect to the x-axis. Okay, so as you see, if my angle is 0 degrees, I'm on point 1, 0. If my angle is, I rotate, and I get to 90 degrees, right? Then I fall on 0, 1, and so on. If I go on 180 degrees, I fall on minus 1, 0, and if I go all the way to 270 degrees, sorry, I'm blocking you, then I land on 0 minus 1, and if I go 360 degrees all around, I fall back again on 1, 0. True? So I'm going to write what I just said here. So this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is, of course, 360 degrees, which is, again, the same place, same position. Okay? Now, there's some other important angles that are interesting for me, okay? And these are this one here, which is 30 degrees, this one here, which is 45 degrees, this one, which is 60 degrees, okay? And I'm going to keep going again, further all around the circle with the same sort of distances between angles. So this is 60, so this will be 120. This will be 135. This will be 150, and this is 180. Okay, here the next one will be 210 degrees, then 225, then 240, 270. This will be 300, 315, 330, and I go back to 360 degrees. Okay, good. So these are points, angles, right? For which the corresponding coordinates are I'm interested in. Good. Questions? Okay. So the first thing I'm going to do is I'm going to show you how to change from degrees to radians. Okay. So let's change to radians. And some of you know what it is, some of you don't. From what I heard last time. Okay, so let's move on here. So measuring an angle in radians. Okay, so how do you measure an angle in radians? Well, here's the formula to change, to convert from degrees to radians. It's as follows. So the angle in degrees divided by 180 degrees is equal to the angle in radians divided by pi. Okay, this is how you convert. Okay, so let's do a few examples. Okay, so let me just move up. So example, convert to radians. So first of all, so let's do a few angles from my circle. Okay, so let's start with 30 degrees. Okay, equals how many radians? Okay, so I'm just going to use my formula. My formula tells me that 30 degrees over 180 is equal to how many rads over pi. And then I'm going to isolate x. So x will be 30 pi over 180. And if you simplify, you will get pi over 6. You understand what I just did?
No.
No? Who said that?
Me, Alexandra.
Okay, so again, how do we convert from degrees to radians? Okay, well, you put, my formula tells me that you put the angle in degrees divided by 180 equals to the angle in radians, x, which is what I'm looking for here, over pi. Okay, and then I'm going to isolate x. So you cross multiply, right? 180x equals 30 pi. And then you divide by 180, you'll get 30 over 180 is 1/6. So x is 1/6 pi. I could repeat again if it's not clear. Alexandra, get it or no?
Yeah, I get it. Thank you.
Okay. Anybody else? Okay. So I'm going to go back up here now. Okay, to my circle. And next to 30 degrees, I'm just going to write down that this is pi over 6. Okay, because I'm putting the angle in degrees, then I'm going to put next to it the angle in radians. Okay, let's go to 45 degrees. So I'm not going to do them all, but I'm going to do maybe two or maybe two. And then I'm going to put the answers, I'm going to fill in the answers myself, and it should be an exercise for you to do at home. Okay, so number 2, let's say 45 degrees equals how many radians? So I do my formula. So the angle in degrees over 180 equals my angle in radians over pi, and I isolate x. And if you isolate this, you'll get 45 over 180. You're going to see that it's a quarter, and so x is pi over 4. Okay, I'm going to move back up here, and I'm going to put next to 45 degrees, I will put pi over 4. Are there any questions? Okay, so I'm going to fill in the whole circle now with the degrees, the angles, I mean, in radians. Okay, so you have to trust me, but you could verify all of them using the little system I showed you right below the page here. Okay, so for 60 degrees, it will be pi over 3. For 90 degrees, this will be pi over 2. 130, this will be 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. 180, of course, is just pi. Okay, 210 is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 pi over 3. 315 is 7 pi over 4. 330 is 11 pi over 6. And 360, of course, is 2 pi. Okay, and 0 is 0. Any questions so far? Okay, let's go. Let's move on. So at this point, what I'm interested in is finding the coordinates of these points on the circle. So these points here. I'm very interested in these coordinates, and you're going to understand why very soon. Okay, if you've done trig before, you definitely know why. Okay, but if not, you'll see. So let's start with the obvious points. Okay, so this one is an obvious one. We spoke about it before. This was 0.10. This here is 0.01. This is -10, and this is 0, -1. Questions? Okay, so let's inspect these points here. 1, 2, 3 points. Okay, these are the most important ones, because if we get this one, well, we could figure out this one because it's exactly symmetrical with respect to the y-axis. And this one, we can get this one because it's symmetrical with respect to the x-axis, and so on. Okay, so once you have this one, you could find these ones sort of the same family using some symmetry. Okay, so let's explore this one here. Just take a ruler. Okay, so let's start with this one here. Okay, so this would be the y coordinate, and this would be the x coordinate, and this is how much? The hypotenuse measures how much?
1.
1. Okay, because it's a circle that has a radius of 1. Okay, so this is 1. Okay, so let's start with this. Okay, so this is 90 degrees. Okay, and so the coordinates of this point will be x, y, obviously. Okay, so I'm going to take another paper because I'm running out of space. So I'll just refer back to this page in a few minutes. So here we go. One second. Okay. Seconds. Trying it to be clear for you guys. Okay, so let's start with what happens at pi over 6. Okay, so let's say the angle is pi over 6. So what do I call the angle? Let me just go back to this page in a second, for 1 second, I mean. So this is what I'm calling here the angle. Okay, so when the angle, I open a radius of 30 degrees or pi over 6. Okay, so at pi over 6, what is that point here? In other words, what's my x, what's my y? Okay, you with me? Okay, most of you guys, I'm sure, have seen this before, okay? But it's always good to see it again. So I'm going to draw, at pi over 6, I'm going to draw my triangle. Okay, so I have something like this. All right, so this is 90 degrees. We have this is 1, this is y, this is x. True. And I know that this here would be 30 degrees. All right, this we know. It's just simple geometry. Can you see, or you want, maybe I should write it in, it's clear now with this pencil. Maybe I should write it in pen, dark pen. I feel that it's a bit clear. It's a bit light, I mean. Okay, so let's go. So 30 degrees. This is 1, this is y, this is x. Okay, so what I'm going to do is I want to draw the same exact triangle under it. Okay, let's do this. So right below it, I'm going to go like this, and I'm going to draw the same exact triangle below. Okay, you with me? So this is, again, this is 1. This is also y. And this is also 30 degrees, because I'm drawing the same triangle under. Okay. All right, questions? Okay, so if this is 30, this is 90, how much is this angle here on top? How much is this?
60.
60.
This is 60 degrees, right? And so this is also 60, because this is 30 This is also 90. So this is 60 as well. Good. So this big triangle, what type of triangle is it? I have 60, 60, 60, right? You see? So this is an equilateral triangle. Okay, so therefore, all sides are equal, and so 2y has to be 1 as well, right? This is 1, this is 1, so this has to be 1 as well. True? Therefore, 2y has to equal to 1. Oh, so y has to equal to 1/2. There's no choice. Do we have any questions before I continue?
Yeah, can you explain the 2y equals 1 and then the y equals 1/2?
Sure. Okay, 1 second. I think I want to need more space here. Okay.
Actually, never mind. Don't worry about it. I understand it now.
It's clear? Anybody else doesn't understand? Okay, let's continue. Okay, so I just found out that the y here is 1/2. How am I going to find the x now?
Pythagore?
Yeah. So we can use Pythagoras theorem to find the value of x. Okay, so basically this is a right triangle, so x2 plus y2 equals 1. So x2 plus y2, so 1/2 squared equals 1, which means that x2 is 1 minus 1/4, which means that x2 is 3/4. And so x is, if I square root, I get square root of 3/2. Okay, so I found y, I found x. Any questions?
What values like did you plug in to Pythagoras' theorem, like from the triangle? Can you just show?
x2 plus y2, that's y2 because y is 1/2, equals 1 squared.
Okay.
Is that okay? Any questions? Let me go back to the circle. 2 seconds. And now I could write down my coordinates for this point. So I know that x is square root of 3/2 and y is 1/2. There we go, I found this coordinate. Is this clear? Who's got questions? Okay, if you have no questions, I'm just going to do one thing before I go to using the same logic. That's why I split the last page in 3 parts, because I want to do it for 30, 45, and 60. Okay, so before I go to continue there, from here, I think that I could figure out what 150 would be. Okay, so what's it going to be? going to go here. Dot, 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 dot. And can you tell me what this point will be?
Negative root 3 over 2, comma 1 over 2.
Very good. So negative root 3 over 2, comma 1/2. Because it's the same y, the same height, but the x is the same also, but now it's negative. Good? You with me? And from here, I could figure out what this one here is. And then I will be able to figure out what this one here is. And they're all sort of the same family. Okay, more or less. Okay, so let me just, can you tell me what this one here for 210?
Negative root 3 over 2, comma negative 1 over 2.
Perfect. And this one here for 11 pi over 6, it will be, anyone?
Root 3 over 2 minus 1 over 2.
And minus 1/2. Perfect. Any questions? Okay. Okay, so let's go now to 45 and let's go to 60. Okay, so let's start with 60 first. Okay, because it's pretty much the same process. So for 60 degrees, I will draw a triangle like this. Here and straight down. Okay, so this will be again, this is 1, and this will be y, and this will be x. Okay, so it's getting confusing. Okay, but what I will do is I will erase the ones that the triangle that I created for the 30 degrees, and now see what's going on with recreate the triangle for the 60 degrees. Okay, so this is y, and now this is x, and this is 90 degrees. Okay, let's go. And this, of course, is my angle theta, which is in this case 60 degrees, or now that we're in calculus, this is called pi over 3. Okay, so you will not use 60 degrees anymore. You will use pi over 3 from now on. Okay, I'm going to explain to you exactly what it means. I just don't want to tell you too many things at once, but how to interpret an angle in radians. Okay, so let's go to the next page and follow the same process. Okay, so I'm going to put this aside for now. And I will draw my triangle. Okay. So I'm going x here and the y here. Okay, so this will be now, let me put down the values. So this is 1, this is 60 degrees, this is x, this is y. Just show you, maybe you could see both. I don't know if you could see both. Yeah, you could see both. Okay, so I just, basically what I'm doing is I'm redrawing this triangle separately here. Okay. this is all this, the purpose is to find the value of x and the value of y, which is going to end up being my x coordinate and y coordinate here, right? The x coordinate and the y coordinate here, okay? So, can you guess what I'm going to do now? Just like I did before, I'm going to draw a triangle, the same triangle right next to it, to the right of it. Okay, and I'm going to put the values. So this is again 1, just like here, 1, 1. This is still x, like here, and this angle here is still 60 degrees. Okay, and can you tell me what these angles are? What's this angle here?
30, 30.
60.
So 30 and 30, right? So 30 degrees and 30 degrees. And so again, I have 60, 60, 60. So this is again, this is an equilateral triangle again. And so this side here also measures 1. So 2x equals 1, which means that x is equal to 1/2. Okay, and we're going to use Pythagoras again. So we can use Pythagoras theorem to find the value of y. Okay, so now we have x. I'm looking for y. So x squared, which is 1/2 squared, plus y squared is equal to 1 squared, which means that y squared is 1 minus 1/4, which means that y squared is 3/4, and so y is square root of 3 over 2. Okay, so all this is for is equal to 60 degrees, or pi over 3. And then we're going to do theta equals pi over 4. And will be set. Any questions? Am I going too fast for anyone? Okay, so this is really not calculus, okay? You're supposed to have done this in high school, but it's okay. It's never hurts to relearn it. Okay, so I now have my coordinates. So x is 1/2 and y is root 3 over 2. Let me go place it right away in my circle. Okay, I'm going to come back to this sheet in a minute. So this is the x we said was 1/2 and the y was square root of 3 over 2. So it's the exact opposite as the 30 degrees or pi over 6. Okay, so let's go right away and find all the corresponding points that we could find right away easily. Okay, so here. Okay, so I'm going to post these notes online. Okay, but it's much more valuable if you could build this circle on your own. Okay, so, because looking at the result doesn't help much if you didn't do it on your own.
I have a question.
Of course.
For like tests or things like that, would we have access to the circle? for this circle?
No, no, no,
No?
absolutely not. Okay, if the test was online, yes, of course, because I have no control over it. But your tests are most likely going to be at the college, so you have to know this. Okay, there's no choice.
Okay. So we'd have to be able to rebuild it during the test?
Excuse
Or?
me? Excuse
So
me?
we'd be able to rebuild it, like make the circle again on our own for the test.
Yeah, but I think you're gonna see these values so much so often that you're gonna know them by heart. Okay,
Okay, perfect.
you're gonna know
Thank
them
you.
by heart. Okay, so let me just right away complete these points, right? Find the coordinate of these points. So this is the same thing, but it will be negative. The x coordinate will be negative. So this will be -1/2 and √3/2. This one here, both are negative. -1/2, -√3/2. This one here is positive negative, so 1/2 and -√3/2. This is this coordinate. Any questions? Okay, let me just get rid of this triangle now and build our last triangle. And then I'm going to try to put everything together. Okay, because for now, we haven't seen any sine, any cosine, so it doesn't look like trigonometry. But for those who've learned it before, you see that you know where I'm coming from, I'm sure. Okay, so let's go with last triangle here. So I'm going to open a triangle right here of 45 degrees. So this again was theta. This is still 1. This is y, and this is x. Okay, so I'm going to take this triangle now and draw it, right? Isolate it and draw it on my little place here, just like before. Okay, so let's go. So let's try like this. So this one is, I think, easier to figure out. Okay, so this is the triangle I'm putting here. So this is, let's put the values. So this is 1. This is 45 degrees. And so this is also 45 degrees, right? Because it's 90, 45, 45. So it's an isosceles triangle, this one. True? Sorry, this is crooked. Okay, so since it's an isosceles triangle, so if this is x, well, this is y, well, it's also equal to x. Okay, because isosceles triangles, sides are the same. Okay, so I don't need to add any triangle. I could just do Pythagoras right away. Okay, so let me write this down. We can use Pythagoras theorem right away, since x is equal to y. Okay, so let's do it. So x2 plus y2 or x2 equals to 1. So we have x2 plus, well, x2 is equal to 1 squared. Right? I should have written y2, but y equals to x, so I'm calling it x. So 2x2 is equal to 1. X2 equals to 1/2. And so x will be, I'm going to square root 1 over root 2. Okay? Or if you prefer, you don't like having a root on the denominator, so you multiply by root 2 top and bottom. And so you'll get x, which is also y, it's going to be square root of 2 over 2. You guys with me? Okay, and now I'm going to go back to my circle. I'm going to put it back in a minute, the triangle. I didn't finish copying. So let me put the coordinates here. So we just found that x is root 2 over 2 and y is also root 2 over 2. Okay, and just like we did before, let's get all the points we could get thanks to this one. Okay, so this one I can get here with the x becoming minus now. So it's minus root 2 over 2, root 2 over 2, here minus minus. And here plus minus. Here we go. So I have all the points of my circle. Okay, so of course you could go online and you could find this circle everywhere. Okay, so this is called the, you know how it's called? How's the circle called?
Unit circle.
Yeah, so this is called the unit circle. Unit because the radius is 1. Okay, so the unit circle. Okay, that's one thing. Second thing that I could say here is, what does it mean an angle in radians? Okay, so what are these values? Pi over 6, pi over 4, pi over 3. Okay, pi over 2. So these are the actual length of this arc. So from here until here, it's exactly, it measures pi divided by 6. So if you go on your calculator, you do pi 3.14159, whatever, divided by 6. Okay, let's do it. So pi, shift 30, 3, no, here. Okay, so that's pi. If I divide it by 6, I get 0.52359 and so on. So this is the exact measure of this arc here. Okay, so if I were to measure, put a string here, straighten it, measure it, I would get 0.52. That's what it means. Okay, and same thing, if I go from 0 until 90 degrees, all this here, I will get pi divided by 2. Do you understand? So it's another way of measuring the angle. If you just give me what's the length of the arc on the unit circle? Well, that's one way to measure the angle. Okay, and it makes sense if you think about it, because the whole circumference of a circle is 2 pi r, right? 2 pi times radius, but the radius here is 1, right? Because it's a unit circle, so it will be 2 pi. Oh, there it is, 2 pi. Okay, so 2 pi r, 2 pi rad, right? Rad is for radians, which is basically another word for radius. Okay, so radius, so radius is 1 here, that's what we just say, rad. Make sense? Okay, so this is all the important points on the unit circle. Okay, we didn't talk about sine, cosine, tangent yet. Okay, but for this I have to prepare another circle. Okay, and this I think we'll do it next class. Okay, and then we'll go through the identities and all the relations between everything in that circle. Okay, any questions? Okay, I think that's it for one day for this. Okay, I'm gonna